Anyways, I emailed you a practice exercise for a final in the same format as we had it for the midterm. So we're gonna discuss it a little later today when more people will join us. And I'm just wondering if you would like me to do any problems in this section 7.3 or any place else. And if you don't have questions, well, prepare some for next class, because that's going to be our last class before the final. So I plan just go over your questions. And in the meantime, I can try to do an exercise for you that I think will be helpful to do before the final. So we already see various possibilities when people do the tests about proportion for a population based on the sample proportion. So for example, if I look at exercise number 10, so if someone applies for the job and have to go through the drug testing, so that's referred to year 1990. Well, I guess this is free textbook, that's why it's a little bit out of dated, but I guess the numbers are still pretty much the same. So they say 5.8% of job applicants were tested for drugs, failed the test. So we looks like have a probability that somebody fails the test is equal to 0.058, right? Because it's 5%, so it's 0.05 and 5.8. So just move the decimal 2 places to the left. So we need to test at some level of significance the claim that failure rate results in a sample of 15, 20 people. So now sample is taken of 1,520, and now they claim that the results are lower. So somehow they decided that people now don't fail the test that often, so the failure rate is lower. So claim is that rate or percentage rate or P is lower than 0.058. So let's check this out. That's what they're claiming. So they have 58 failures. So out of 152, 58 people failed the test. So I can say that P with a hat, that's sample proportion, out of 15, 20, 58 failed that test. I can actually divide this using my favorite scientific calculator. So let me go here and find the scientific calculator here. So the first choice, right, decimals. So we got 58 divided by 1,520. So I guess convenient will be to work with the actual decimal rather than that kind of nasty looking fraction. I can round it. I can write this as a 0.038. 0.38. Notice I put it in the same format as that 0.58 with 3 significance after the decimal point. So P is here. I need its friend Q. So Q is always 1 minus P. So we're gonna get a Q this way, and then we'll set up the whole process. So it looks like here we have the decimal, which is 942, right? 0.942, that's my Q. Well, so let us finish up with the setting of hypothesis. We need to put this in H1, right? Claim is in H1 because it does not have equal sign. Its opposite statement, H index 0, is going to be P is not less, but then greater or equal to that 0.058. So equal sign must be in H0 always. So let's picture H1 and start the process of testing. Picture will be on the left side, isn't it? On the left side because it's lower. So here's my H1. H0 is always on the other side. And we care about the cutoff, the critical value of Z that corresponds to this last number that I need to utilize in this exercise. And they told us 0.01 significance level. So 0.01 is going to be the area. And now I have to use tables, right? So let's go for Triola tables. So how do you remember this word? Well, that's the name of the author of the textbook. So if you forget it, you can always type the name of the author and put tables or formulas and you will get there. And it looks like we have 0.01 to locate among those negative z-scores, the closest number to 0.01. And I think we already encountered that number. It's in between 99 and 102, because that's like 0.0100 if you put extra zeros. So the closest is 99 to it. And this way we get this z-score found. Yes, please tell me which exercise you would like me to do for you, and I will be more than happy to look at it. Just tell me which one you would like, or if you can't make a decision, I can just select myself. It's also fine. So it looks like 300, so I have to attach to 2.3, so it'll be like negative 233, right? So it looks like we're gonna now recall the formula for a z-score using population proportion. So we had to go p hat minus the p for the population and divide this by EQ over N. So it looks like we now need to carefully put the numbers in. We have all of them, and that's the good thing. So for the p hat, we have 0.038. Then for p, we're gonna use the one that appears in our claim, 0.58, 0.58. And then denominator, we get a square root from PQ. So that's 58, 0.58 times 0.942, right? That's a Q, the complement. And I divide this by sample size 1520. So this is what I need to enter in the calculator and the parentheses necessary for the upper part. Okay, so let's do this. Take this numerator parentheses, 0.038 minus 0.058 in the parentheses, and then I divide by square root from 0.058 times 942. So I hope that you are also entering this in your calculators, so we see what the answer will look like, and what the answer looks like. I think that something didn't work, right? So we 942. What's going on with my calculator? Why it doesn't give me the answer? I'm a little bit surprised because I have this entered 1520. Maybe there is something wrong with the calculator. I'm not sure what happens. I think, yes, I see it. I put a comma here by accident. It's a point. See, so sometimes you need to be really careful with this, and it's good that I found it. So we got a z-score. Looks like this is negative 3.335 ... Okay, so where are we? H0 or H1? Where is that z-score? 3.3 is all the way here to the left, isn't it? Because it's -2, -3 is on the left side. So it is here, it is H1. So say yes to H1. So I supported my claim and did not support H0. So we just proved that whatever they claim is correct. So people did start to pass the test, I guess, more often. Proportion of people that passes this test is greater, and that's all. So now the equation came from sections that I'm not covering for this class, because we did 7.3 and 7.4, and I told you not to worry about 7.5 and 6, because turns out they deal with a different distribution, with a T distribution. And I can actually say a few words about it if you want me to, because technically this distribution is designed for small samples. It's actually whenever you have your sample size less than 30 elements, and oh yeah, because I don't think there is a point of doing it, but turns out the only difference in these sections is when you have small samples. The reason is when you have small samples, it's not gonna look normal, and that's why they use a special distribution called T distribution. It's actually right next to it. I used to talk about it in my other classes, but then I figured that that's not as crucial because z-scores are pretty close, and it's not designed for so many scores. It's just for few specific cases. So notice that in this case, when you were looking at the significance level alpha, which is 0.01, like in our exercise. So notice in that distribution, this is a first column, 0.01. And actually here, because it's one-tailed, 0.01. So it's a column number 2 here. Then notice that our z-score came out to be 2.33. And notice that 2.33 is here. So it's corresponding to actually a very big sample size, like 2000 or something, large sample. And if we have small sample, 10 elements, 15 elements, well, the critical score is getting actually smaller. It's getting larger. So we need to, I guess, get bigger samples in order to get a normal distribution. Because if you just have considered only one element sample, then your critical score will be 31, which is huge. And that's why they designed a different distribution. The process is all the same, but you just used this special values from t-table. That's different distributions, close to ours, but a little different. That's why, yeah, I didn't go over it. I'd rather spend more time on probabilities, and that's, I think, a little bit less tedious. So anyways, let me discuss what be on the final. In fact, I sent you email this morning that contained the practice exercise that I would like to introduce right now. The practice problem, because we have a final on Monday next week, which is going to be a week from today. So Wednesday, I'm going to discuss homework questions of yours, and I'm glad that you are interested. So I hope you will bring me with just about anything that you want me to do from the homework. And for now, I'm going to go to the exercise that I emailed to you, and I'd like to do it. And what I'm using here is, as usual, remember for midterm, we also had last digits of your student ID to do the exercises. So in this exercise, I asking you to use the last digit, very last digit, which I made up as a 6. If you want me to use some other digit, just tell me, I will use the other digit and do this exercise. So it says that here we talking about the percentage of TV households that actually watching the particular TV show, and they say rating is 7.8, which is corresponding to 7.8%. Well, that's clearly letter P, percent, right? 7.8, and we never write it as a percent, we always write it as a hundreds, right? So if you divide by 100, you're going to end up with 0.78. So they gave you P. Okay, so now they consider the 100 households. So that's sample size, that's N, always the same, always letter N. And we want to use B plus 1 here. So sounds that nobody asked me for any other digit but 6. Okay, so my B plus 1 will be 6 plus 1 then, which is 7 in this case. If your last digit of student ID is 0, then it's going to be 1, or if it's 9, it's going to be 10. So whatever, you're just going to utilize this in the exercise. So they say that survey of 100 households find that at least, remember that word, at least, we heavily utilized it, right? 7 were turned on that TV show. So find the probability getting at least turn on that. So probability is always. So that's what I have to find. Okay, so let's see how we used to find it. First of all, I utilize X, right? At least means it's not less. It has to be either greater than or equal to 7. And notice that in this exercise, we don't have mean and we don't have a standard deviation. We need to find those using formulas for binomial distribution. It's a binomial distribution exercise. So since I'm doing it, I need to do continuity correction. Remember what that was? If we're dealing with 7, then I will get this bunch of bars, and 7 will be in the middle. Previous is 6, and next is 8. And they told us we must have 0.5 increments, like 6.5 or 7.5. So that's what's going to be approximation of this. Approximation of what? Of equation that they posted in our exercise. X is greater than or equal. So equal to 7 is included. 7, and then greater means it's all the way to the right. So we have this. So this is 6.5. right, in our approximation. So that's exactly, I guess, your request. You wanted me to do exercise from another chapter, so it's exercise from the previous chapter, which is actually going to appear on that final exam. So I think it's a great idea that you asked. So anyways, 6.5, as you can see, it's on the board, right? That so-called continuity correction. Whenever you don't have your mean and standard deviation, you need to get approximation. The reason why you're doing it, because you're going to need to be able to get the area using the z-score story, the normal distribution. And the normal distribution needs a z-score that will correspond to your value that you produced by that continuity correction. And the formula was always the same. I think I took lots of room, so I need to maybe clean a little bit here on the right. So I'm going to use the z-score formula, which is x minus mean over standard deviation, the favorite formula of ours. So x minus mean over standard deviation. And here my mean is a NP. We just recall this here, right? And the standard deviation is a square root from NPQ. So z-score formula, as usual, is going to be in use. So let me put some numbers in it. So we now need to get to the actual story of x. So the question is, what is our value of x? It is approximated to 6.5. Next is NP, and this is N100, and P is 0.78, right? That's the only number they gave us. And then I also need its friend Q, right? So I'd be able to calculate my denominator. So let me subtract from 1, right? So as usual, when you have P, automatically you get a Q, so you subtract 1 and that 0.78. So this is 0.922. You can double check with a calculator. 922, and it looks like we're ready to enter this in the calculator, get a z-score, and answer the exercise. So let me go here and put this a little bit cleaner way. Okay. So I put parentheses around my numerator, 6.5. See, we just get enough information. And all of these exercises, they always give you enough information to solve the problem. So if you have extra numbers, then probably something is not set up correctly. So divide this by a square root from 100 times 0.078 times 0.922. Okay, there we have it. There is my z-score. Z is negative 0.48. We can't really do any better than that because we can't use any better approximation from our favorite tables, but hundreds. Let me go to the table of hundreds and get 0.48 in this table. So I need to go to negative 0.4. So the row was negative 0.4 and a column 0.08, right? So that's how we always use these tables. And to get to this spot, I better clean this a little. So we have the intersection of 0, 8. So this is the column. And this is the row. So we got the number. There it is. It's area from the left. Remember? So the area from the left is what I found. It is 0.3156. Do I need that area? No. I need the area on the other side. I need this area, right? Because I highlighted this area. That's a complement. Subtracted from 1. We're using these complements all the time in this class, right? So here's my answer. 0.6844. I just got the result for that exercise. How about that? So that's how we're going to work out similar problem on that final exam. I guess that's pretty much all you're gonna need to look for. And the other exercise I will ask you from this hypothesis testing, I guess maybe next time it'd be a good idea that we do another one from this hypothesis testing story. I believe it'd be good if you do a little bit of homework and maybe find some questions. And yes, it'd be pretty much same exercise, same story. Because I know that sometimes people see the different story and they get panicky or something. Yeah, I'll put same story, just put different numbers. So I'm sure you will make it with that. So one exercise will come from the chapter with a approximation. So let me show you those sections. And the other exercise will come from the chapter with hypothesis testing. So it looks like what you're gonna need to do is take a look at, I believe, chapters 4 and chapter 7. Let me go to the content so we can better see this. So this problem came from section actually 5.6, sorry, chapter 5.6. That's the exercise where I picked it from. And the other exercise will come from 7.4, the other chapter that we just looked at. And in general, for the homework, I was asking you for the problems that relate to 2 sections from chapter 4 for the homework, for the final 4.3, 4.4. Also, chapter 5, we had sections 2, 3, and also sections 5 and 6. That's for chapter 5. Then we moved to chapter 6 and did a couple of sections 6.2 and 6.3 in it. 6.2, 6.3. And finally, in chapter 7, we did 7.3 and 7.4. So these sections are for homework, and the most of concentration you can do on these 2 sections, and look at some exercises. And if you would like me to do some for you, so on Wednesday, the next class meeting, I will be just answering your questions related to the final. I will do another exercise. So I just show you one problem from 5.6. So I will show you the second problem from 7.4. Well, you already know where it comes from, but I'll try to find the problem analogous to what I put on the final, so you see this closer. And that's pretty much all I wanted to talk about today. So just to start a review, and I guess that's, I guess with me. Okay, so we got the, I think I will stop at this stage.